Hey everybody, it's Dr. Jensen with CCJ3701, Research Methods in Criminology. So we're here with part 2 of tips and help with lab 9, your last lab. And we left off where we were looking at another variable you're going to use to analyze a question about getting arrested. So in the question it also looked at the respondents' parents' marital status when they were younger. There are all kinds of theories of delinquency and certainly adult offending that have to do with kind of disrupted childhood experiences and challenging marriage experiences and having multiple partners. For some theorists and some researchers has been identified as a risk factor. But now that we have these kids in adulthood, we want to know if it matters at all. You know, once they've gotten into their 20s and 30s, does it still present a risk factor? Or is it kind of normalized? You know, does it even matter? So we're going to make this single parent versus married variable. So again, in the value labels, we have married is 2, single and never married is 1, 3 is widowed, 4 is divorced, 5 is separated. You see these little instructions in parentheses? Those are just notes to the researchers to say, hey, we prompted them for more information on these experiences by going to or skipping to a new section of the survey. Doesn't really have anything to do with us, but it's there for kind of notes purposes. So you need to recode this variable and basically make a single experience versus married experience. So this goes back to conceptualization and operationalization. As a researcher, you get to decide what you mean by single. Does that mean you want the single never married people and you're not going to include the separated people? Do they have to go through a legal marriage and then a legal divorce? What about people that lost a spouse to death that are widowed? What about people who cohabitate that aren't legally married, but they do have a partner? These are all things you'd have to think about and decide what to do before you make your coding decisions, okay? Because they're going to tell you different things about people and reflect different experiences about them. For purposes of the lab, we're going to keep things kind of straightforward and just kind of do all these different statuses. So our singles, our widows, our divorced and separated versus our marrieds. So you're going to make your 1s, 3s, 4s, and 5s a 1, meaning you've experienced some kind of single relationship where you were not married, versus our 2s, which we're going to make a 0, meaning you were married. Now we know that people's relationship status changes a lot over time, but we want to know if just having any kind of change for these kids in their childhood made a difference in things that happened to them later in life. So that's how you're going to go about that variable. So you'll want to go ahead and recode that and write down the coding scheme you used. Then I ask you 2 questions. We have 2 other variables in this analysis. One is gender. You need to use biosex 4 because that asks them their gender when they're older, assuming sometimes people change their gender as they get older. So it's saying, okay, right now, are you male or female? Okay. So you need to look at that variable to see if it needs to be recoded. It may not. Okay, but we are interested in males' experiences versus females. So go take a look at that variable, biosex4, and it is bio_sex4, to go see if it needs to be recoded. Okay, the next variable, sorry, that should be number 7. You need to recode the arrest variable, which is H4CJ1. Okay, let's take a look at that variable. So each of these variables have different attributes. Most of these variables are nominal, meaning they're categories or certain responses that put you in one group or another. Let's go ahead and type in a control find of H4CJ1 and find that arrest variable. So this says, ever been arrested by police, wave 4. So have you ever, in your whole life, have you ever been arrested? You can look at the value labels here. It's kind of a yes, no. This is perfect for binary logistic regression. We want to know if this happened versus this. When you have a dependent variable that's categorical, that is perfect for logistic regression. This experience versus this experience, okay? So you have to decide if this needs to be recoded as well. And once you have all your variables organized, the parent variable, gender, arrest, and your drug scale, now you're ready to run your analyses. Okay, so then it gives you those instructions. Run a regression that assesses what if using drugs, predicts the likelihood of people get arrested by age 32, considering whether you're male, if you experience a single parent household in your youth, and then write your results both statistically and substantively. So What does this mean in English? Let me show you what your results should be once you have all of these done. Okay, so this is kind of like the answer key that you can check once you have all your stuff created. You can make sure you did it correctly. I can grab these screenshots so you can see it. So when you get ready to run the analyses, you go to regression, binary logistic. Okay, this is the regression that I ran, and if you look at this carefully, it kind of gives away whether or not you should recode certain variables. So you could pause this and look at this, and it could kind of tell you. So you put your dependent up here, and your 3 variables down here that we've been working on. You click OK, and you get this output. Okay, so remember, it starts up here with logistic regression, shows you how many cases you analyzed, and then you kind of start scrolling down. You don't use this stuff at the top really. You scroll all the way down to the bottom until you get to model summary, classification table, and then variables in the equation. So remember, model summary, we use the Nagelkerke R-squared. So this tells us that we can cover about 20% of the reason that people get arrested. Of all the reasons that explain them getting arrested, we can cover about 20% of those reasons, which isn't bad, but that's not great. Okay, variables in the equation. So in us trying to attempt some little curvilinear line that describes how these things are related, this is what we get. So again, we don't really interpret these B values. Move your eyes all the way to the right and look at the significance levels and the exponential B's. In your lab, I gave you some tips, just like the last lab. So on the very back page, it says interpretation hints. You have to understand odds ratios, or the probability or likelihood of something occurring. Remember, we use the Nagelkerke pseudo R-squared. Kind of similar to what we interpret in linear regression. 0, it's not really predictive, to 1, it's perfectly predictive. And you can kind of treat it like a percent, how much variation it covers. Okay. And then I also talk about here what these little odds ratios or these exponential B's actually mean. If it's greater than 1, your outcome is more likely for one group over another. Or if it's exactly 1, there's really no difference. If it's less than 1, then it's less likely for one group over another. So it's pretty straightforward interpretation. And again, you can state this in a variety of ways depending on which group you want to talk about. Most of the time we talk about the ones experiencing that change compared to the zeros. When you interpret odds ratios of nominal variables, and the likelihood is more or less likely for the ones versus the zeros. For interpreting the odds ratios of interval variables, like your drug scale or your drug summation, it means the likelihood is more or less likely for every 1 unit increase in that variable. So for every additional drug you use, you experience this higher likelihood or lower likelihood of being arrested. And again, just a reminder of how to interpret those little significance levels with the little p-values, the probability that it's true at the 95% level, the 99% level, or the 99.999% level. So significant, significant, highly significant, meaning we have a very low chance of being wrong. Okay? So use those notes on the back to kind of prompt you through the things you need to write about. You need to record the statistical information you get from SPSS, mostly in this box. And then you need to write it out in plain English, and here's some help to do that. So in this drug usage scale, you have a exponential B of 1.317. So it's greater than 1, meaning it's more likely, but it's just slightly more likely. So you could say it's 0.31, like 30% more likely. For every additional drug someone uses, they increase a 30% chance increase in getting arrested. So it's kind of subtle. It is highly statistically significant. So we can tell that just using drugs greatly increases, or at least modestly increases, your chances of getting arrested, especially with every additional drug you use. Okay. Being a single parent, is this one significant? No, it's not. So if it's not significant, you don't really need to go into what this little exponential B is, because we can't rule out chance it's actually true. Let's look at the males versus females variable. Wow, that's a huge odds ratio, 3.3. So just being male greatly increases your chances or likelihood of being arrested. Because remember, all of these little exponential b's are the likelihood of getting arrested. Okay, and it kind of reminds you up here, your dependent variable is getting arrested. So what are the chances or probability of getting arrested? For males, it's a lot higher. They are 3.3 times more likely to get arrested than females. Okay, and that is highly significant. So yes, there is a relationship between gender and getting arrested. So we have kind of a mixture of results here. Those are some ways you can start to write about them. And this might be the regression you choose to run if you're just interested in things happening or not happening, or the chances of something being one thing or another. This is the kind of analysis you could do. But again, you have to make sure that your variable your variable is prepared properly before you stick it in the equation, so that you meet the assumptions of the technique and it fits the criteria, that you have enough cases to run. We have several thousand cases in here, so we're actually in pretty good shape there. Because we do need a large sample size to do this. And again, we have to be kind of careful with interpreting our drug scale because we don't know exactly how many questions everyone answered, but generally speaking, we can say, well, we're confident that when you use more drugs, you increase your chance of getting arrested a little bit. Okay, so hopefully that gives you some help in getting all this wrapped up. I don't want to walk you through everything step by step because I want you to become competent in doing things on your own. So you may need to lean on a classmate or a lab partner just to double check your work and help a little bit. But I'm excited to see how you guys do. This is kind of the epitome of all your skills coming together, and it's fun to kind of finally get that right answer. So good luck, and we'll see you next time.